As promised in the last video, we're now going to learn to use the definitions of our logical connectives and the truth values of the component atomic sentences to determine the truth of complex sentences in truth-functional logic. Our aims in this lesson will be to first start by distinguishing truth-functional and non-truth-functional connectives, and then we'll work on how to construct a truth table for a complex sentence of truth-functional logic. So far, the logical connectives we've studied have all been truth-functional. What this means is that the truth value of complex sentences built from any of those connectives and atomic statements will depend on the truth values of those atomic parts. The possibility of determining the truth value of the whole given the truth value of the parts is only possible with truth-functional connectives. But not all connectives are truth-functional. Because is an example of one that isn't. So if we take a sentence like, the tomato crop was small because the plants were eaten by pests. That whole sentence is true, and both constituent sentences are true. So the constituents were the tomato crop was small and the plants were eaten by pests. But just because the two parts are true doesn't always make the sentence as a whole true. Contrast the sentence we just looked at with the tomato crop was small because the moon orbits Earth. Both constituent sentences are true, but the sentence as a whole is false because the second part doesn't explain the first. Because the truth value can vary, even though the truth values of the constituents are the same, this is not a truth-functional connective. Another example of a non-truth functional connective is called the subjunctive conditional. This is an if-then statement that doesn't fit our mold for the logical conditional we've studied. Subjunctive conditionals ask us to imagine what would have happened if circumstances were different. So, for example, we might hear, if the vase had been dropped, it would have broken. Contrast that with, if the vase had been dropped, it would have transformed into a unicorn. You should recognize that the first is true, but the second is false. The problem here is that the subjunctive conditional is one that can't be expressed with the logical material conditional because, like the phrase because, it's not truth functional. If we look at those examples, in both cases, the antecedent is false and the consequent is false. But only the first one is one we would say is true. So again, like with because, the truth of the whole sentence doesn't just depend on the truth values of the parts. It depends on something special about the relationship between them. We can contrast that with our indicative conditional. That would be something like, if the vase falls, it will break. This is a sentence that can be expressed with the logical material conditional because as long as the consequent isn't false when the antecedent is true, that statement will be true. With the truth table, we try to determine the truth value of complex sentences that use truth-functional logical connectives. Our goal is to assign all the possible combinations of true and false to all the simple sentences in the formula, and then we use those assignments, plus the definitions of the logical connectives that we looked at in the last video, to determine how the truth or falsity of the complex sentence depends on the truth values of its parts. Constructing a truth table is only possible because the connectives we're focusing on are truth functional. So here we have a truth table for a specific complex sentence, the negation of P and Q. The first two columns of this table list all the truth values that P and Q can have. And then the third column gives the truth value of the complex sentence in each of those circumstances. In a moment, we'll go through the steps for how to construct this particular truth table. But first we're going to look at an overview of the instructions for building a truth table for a single statement of propositional or truth functional logic. Start by listing all the constituent simple sentences and then list the sentence itself. Second step is you have to assign all the possible sets of truth values to the simple sentences. And we'll see there's a straightforward rule to make sure you have all the possible values. If there are n simple statement types, your table needs 2 to the n rows to capture all the different possible valuations. Once you have the assignments of truth values to the simple sentences, you can work through to get the truth value of the complex sentence, starting with the connectives with narrowest scope and working to the connectives with wider scope, finishing up with the truth value under the main connective. That will give you the truth value of the whole complex statement. So let's look now at our example, not P and Q. We start by listing all the constituent simple sentence types and the sentence itself. So we have a column for P and a column for Q. Those are our 2 simple sentence types. And a column for the sentence itself, the negation of P and Q. The rows of the truth table represent the different valuations in the table, that is, assignments of truth values to the simple sentence letters. So our goal is to get all the possible sets of truth values for those simple sentence letters, all the possible valuations. And again, the rule is if you have n simple sentence types, you need 2 to the n rows. So here we have 2 simple sentence letters, P and Q, so we need 2 to the n, 2 to the 2, or 4 rows. Then we need to assign true and false to P and Q so we get all the possible combinations. There's a pretty straightforward rule for doing so. Once you determine how many rows you need, go to the first column, make half the rows true and the second half of the rows false. So here we have 4 rows, and if you look under our first column P, we've got half 2 rows as true and half 2 rows as false. In the next column over, you write half as many trues in a row and half as many falses in a row. So here, since we only had 2 in a row in the first column, we only have 1 in a row, or we alternate every other. Now we've assigned all the possible combinations of truth values to the simple sentence letters. So our job will be now to work using those assignments to assign a truth value to the complex sentence, given the assignments for the simple sentence letters. And we start with the truth value under the connective with narrowest scope and work to the connective with wider and wider scope. The truth value under the main connective determines the truth value of the whole complex statement. If you're feeling uncomfortable with the notion of scope, this would be a good time to review it. So this sentence that we're looking at only contains 2 logical connectives, negation and conjunction. Conjunction has narrower scope, it's within the scope of the negation, so that's the one we start with. Then we go row by row. We look at the value of P and the value of Q and say, what would the truth value of P and Q be given the truth value of P and the truth value of Q? Since conjunction is only true when both conjuncts are true, P and Q is only true in that first row where both P and Q are true. So if you look at the last column, under conjunction we have T for true, false, false, false. To complete our truth table, we have to determine the final value of not P and Q on each possible valuation. Since the negation looks at the complex sentence in its scope, and we don't have any other simple sentences to consider, we now no longer have to look at the first two columns. To determine the truth value of the sentence, we only need to look at the truth value of the conjunction. We have to determine how the negation, the main connective, affects the truth value of the conjunction in its scope. And negation's rule is basically switch the truth value. If the sentence in its scope is true, the negation is false. If the sentence in its scope is false, the negation is true. So that gives us the truth values under each of these valuations: false, true, true, true. That final column under the main connective, the negation, shows the truth value of the complex sentence on all possible assignments of truth values of the sentences that make it up. In our next lesson video, we'll look at another slightly more complex example to get you more familiar with how to use truth tables. And again, it may be worth reviewing the part of the previous lesson on scope and on main connectives if you feel like you're not totally confident with those concepts yet.